cornfield we're in, we have the added advantage of having irrigation underground. So in this particular field, we have drip irrigation installed at 40-inch centers and at 60-inch centers. So we're doing a lot of research saying what spacing of tape is the most economical. But where we're at here, we can see that this corn has already got roots right down into the drip line. And as we dug here, we cracked some of these off, but they're right here, we're feeding in this zone. So with this drip tape 18 inches underground, this being a corn-on-corn field, it gives us the advantage of being able to do tillage, massive tillage, with a V-ripper with the bullet ripper points over the top in the fall after harvest. So let's go in depth and talk about why drip tape when we know that there could be pivot irrigation put in a lot of these fields. Without question, it's more expensive. It's not quite double, but it's common to be in that $1,900 to $2,400 an acre, depending upon the layout and the design. 40-inch is dramatically more expensive than 60. But in our case, we're in 20-inch rows. And so 40-inch seems to fit our pattern very well. Roots will feed, and you have the advantage of being 100% efficient with water. We probably should say 99.9. But all the water that we're emitting, there's no evaporation. The interesting thing is, in all of our research over the last 3 years, we found that water comes up twice as fast. It'll migrate and come up to the surface twice as fast as it goes down with gravity. So it'll come up 12 inches and go down about 6. It doesn't take very long at 18 inches deep, and you would start to see circles of moisture on the surface around the corn plant. And then it just starts to spread. It's not like a pivot irrigation where the top gets extremely wet. It's just moist, and you can take your hand and scoop that dirt up and run it between your fingers, and it's nice and moist, but it's never muddy. So it has a lot of advantages of being to feed this crop in what we call spoon feeding. So we've started this particular drip system, and you can see that the emitters are starting to emit water. In this case, this tape, they're every 24 inches apart, it has an emitter. And so over time, it's very common we would give it 3/10 to a 1/2 inch of water in one application. We can feed in, and we'll go up to the drip station and show you in detail. We're able to put nitrogen, sulfur, P and K, and all the micronutrients right into the water system. So this root here is very, very happy keeping this plant running at top efficiency. I started doing and thinking of drip tape back in 2012. It was a once-in-a-generational drought for me. Extremely tough conditions. And so we had 250 bushel corn ground yielding 60 to 70 bushel. To the south of us here, I had 1,200 acres of corn that only had 2.3 inches of water from planting to harvest. So you can quickly perceive without irrigation, we were in serious trouble. The frustrating thing for me was it really started to take effect about June 15th. We had already preloaded all of our inputs at that time. So I was sitting on dollars invested of inputs for 250 bushel, and in the end only harvested 70. And I remember calling home and talking to my wife and saying, I'm going to change this. And I immediately started to research, because I knew in California and out west they were doing drip irrigation, shallow, in vegetable fields, 2 to 3 inches under the surface. The most I could find that ever put it was 8 inches. I knew if we come into the Midwest, we were going to have to start doing research much deeper if we're going to do any type of tillage and not in any way damage this tape. So in 2013 and 14, we started to lay research plots, and we went in that 18 to 16 inch zone, and since then I'm probably more down in the 22 inches because I found that water in our soils migrates very, very quickly to the top. In 2012, our nitrogen system was a side dress bar, and we had put a colder mark right down the center of our 20-inch row. That ground opened up through the drought of June, July, and August to an inch wide, 20 inches deep, and then the ground fractured every 20 inches down the row. So you just think of it as an ice block, a 20 by 20 inch ice block, that if you'd have put an anchor in it, you could have picked it right out. The scary thing was that corn was under extreme stress in August because that cracking and opening of that scorn mark with the colder snapped every number 3 and number 2 crown root going down. When I talked to my agronomist, Ken Ferry, he said, we've probably lost 50 to 80 bushel in this drought just due to all the roots snapping. So the number one challenge that I said the drip itself would be worth to me in a drought year if I could keep my soil together and it wouldn't dry out and start to collapse and open up. And over the years, I can tell you with no question in my mind that drip tape will keep the ground in a natural state and it will not open and collapse and dry out because you have the ability to keep this soil in the perfect moisture level. So being able now to spoon feed a crop, we'll come in and we'll have on 60 to 100 units with the planter. And then about this time of year, we'll start feeding. And it's common we'll put 10 units of N on a week. Always with sulfur, because we know that there's always the risk, and you can see it, pick it up right here. I can see sulfur striping in this plant. So we'll spoon feed sulfur in at a 1 to 10 ratio. In other words, 10%. So we always feed sulfur as we feed nitrogen. We've done a lot of research of micronutrients, P and K, and the results have been very, very promising. I would say this, and I'm giving you all the advantages at this time. And so this is all the frosting that we're talking about. I would say there's 80 to 100 bushel yield advantage over dry land to a drip irrigation system. We've got growers that we know in Kansas and around the country that have had very, very good success. The disadvantages are this. Number one is cost. Number two is it's really an ugly baby when it comes to putting it in the ground. There's no way you could put any smile on it. It's hard to install. In our case, we're using a 6-row applicator, a man for every roll of tape. About the most length you can ever get on tape is 5,000 feet, so you're making a lot of joints. Anytime you make a joint, always there's a concern it would leak. But at the same time, over the 3 years, we've done pretty well with installation and leaks. So when you come into a field, first and above all, it must be designed correctly. The drip advantage is you don't need as much water as you would in a pivot irrigation. So when you think about a pivot, you got that 1/4 mile arm going around, it takes a massive amount of water. Probably 700 minimum gallons per minute, up to 1,300. We've got wells that'll pump 1,600 gallons a minute. But in drip, it's a totally different system. You can go much slower and you do it in zones. So if you told me you're limited on water and you believe that you can't get 1,000 gallons a minute, but you could possibly get 350 to 400 gallons a minute, then drip becomes in your sweet spot because you can do it in zones and you can do it over time. And so as we talk about watering, it's common that we would water in 8 to 10 hours. We could put 3/10 of an inch on the whole field. And when I say whole field, I'm talking about the irregular shape into the corner. And it doesn't matter if the field's long and narrow or square. Drip fits any situation. Up over grades, tape itself comes with pressure compensating emitters. In other words, these emitters would have a little check valve, and so you can take quite a bit of grade. I've talked to a grower at a farm show. He had 60-foot hill valleys in his northwest Iowa field, and this tape was running an equal amount due to the pressure compensating design in the emitter itself. So grades are not a problem. It comes down to understanding, though, it needs to be engineered correctly. The next thing you would do, you'd come in and lay all your mains and sub-mains. Usually we would lay 18 inches deeper than this tube. We would have a trench here, and we would lay, example would be this 3-inch PVC, another 18 inches below this, and then we just use a riser that would come out of the PVC submain and rot into the tape itself. And so there's a lot of time that goes into installation. Round numbers, I would say an 80-acre field would take every bit a week of a team of 5 to 6 guys to get installed. So other negatives would be then mice bites and just leaks that would occur from installation the first year or two. You'll find all those. So in other words, any of the risers that come up that separate from the tape that would be running a half mile through the field would come apart. You'll quickly find that. There's a large wet spot. It's just a matter of getting down to your elbow in the goo to go ahead and repair that. But pluses and minuses put aside, at the end of the day, my motor gets running pretty high on this because I think this is the future as we go forth. We talk about water efficiency, high yields. We're able to take a field at the dairy and we're well over the 300 bushel mark in a field that dry land never made 200. So I think there's a lot of pluses. I think we need to have our eyes open when we go into it and understand there's minuses. Number one being cost. Number two is being installation. And then just maintenance of holes due to mice bites or just leaks that occur throughout the wintertime season. All in all, though, it's a lot of fun working with drip irrigation. Up here at the drip station, we have a lot of technology that really helps us as we do our research or as we just water a standard cornfield. In this case, we have a well that's about 110 feet deep that has about 1,300 gallon per minute capacity, more than enough for the 87 acres that we have here under drip. We then come out of the well and we come into our filtering position because iron is always a concern. We worry about the emitter if we have a large amount of iron that it could always, over the years, tend to start to build up and decrease the capacity of your system. We believe that these systems have the capability of going 25 to 30 years. I know of a farmer in Kansas and also Kansas State University. They've been operating for 33 to 35 years with drip tape. So as the water comes into the sand pots, it's filtered and it keeps it in a good condition so that it then goes out through the different zones. In this case, we have 17 zones because we're doing research here. We check different levels of nitrogen, different levels of micronutrients, and so every 120 feet in this field, starting at the road working south, is a different zone. So the length of row is approximately 1,600 feet, but every 120 feet, we have the capability to put on a different amount of water and any type of different nutrient that we want. So we're heavy into research, whether that's in corn or in soybeans. The actual injectors that you see behind us have the ability to inject at the right amount into the water stream, an accurate setting, a very measured amount. It's pulling off of that 1,500 gallon tank for nitrogen that we have over on the side. So we can control these systems off our iPhones and iPads. We can select the zone, we can start the injectors. We have full capability from our desk or actually from our pickup. So as time goes by, we'll continue to research more and more and try to measure exactly what's the economical return to a drip system, either on 40 or 60 inches, 18 inches under the ground, where at any given time we can come in, let's say every 3 days, and give it 1/3 of an inch of water. Some of the challenges that we face going out into a field and putting a drip station is how do we get power out here? In our case, we brought 3-phase 480 volt power in that runs our 75 horse irrigation motor, plus all the little individual motors on our injection stations. There's growers though that have drip very running successfully off of large holding ponds or a lake, or even off of a river. They're able to draw water. It's less water needs per minute on a drip than it ever is on a pivot. A rule of thumb that I always use is about 5 gallons per acre. So if you're going to have an 80-acre system, I'd like to see if you could draw about 400 gallons a minute to keep it running efficiency. We talked about the filtering and the sand pots. Depending upon your iron count and the size of your system would be how many pots you would need in a row. They have the ability to sense pressure on the end filter as the water comes out and they automatically discharge and recycle and rinse. In our case, our discharge goes right down a 6-inch tile and right on down through the tiling system. We realize that having sub-mains at 3 feet deep at 36 inches and drip lines at 18 inches, coming dead of winter, there's a real concern about frost, especially if we would head north into Wisconsin, Minnesota, where we know that it can get frost as much as 5 to 6 feet. So in our case, we just rent a heavy commercial air compressor, and after harvest, we open up our flush lines and we blow the whole system out. We drain all the system you see here behind me, and we flush every line, every 40-inch line running through the 80 acres, including the sub-mains, with air. We blow the whole system out. We're careful that we never go over 35 PSI on the system as we're draining it for wintertime. In the last 3 years where we've used commercial air to blow out our systems, we've been very successful on startup in the spring. When we come out in the spring for successful irrigation season, we'll start up each zone one at a time. We'll take a gator and drive the zone looking for a large area of really moist or even standing water that's coming from a rodent bite or where some type of a joint that would have come apart. After the first 2 years though, and you get through the initial installation, we would see about 10 to 15 repairs in an 80-acre field. We talk about the depth of the tape. We're always concerned about any type of damage that could happen. 15 harvests was not that long ago. I can't remember all the times that we pulled combines out or even auger wagons. And we think of a deep wheel track that's in that 8 to 12-inch zone is why we moved from 18 to 20. We've even had the unfortunate mistake of having a ripper go exceptionally deep and it hit tape at 18 inches on the second pass where the wheels couldn't sustain a 12-inch level. Those are when you get really good at repairing drip tape.